Welcome back to Chemistry Lab. Today's topic, atomic absorption spectroscopy and hard water analysis. You're going to analyze a tap water sample for hard water ions. Calcium and magnesium are both hard water ions. We're going to have two atomic absorption spectrometers set up. One of them ready for you to analyze for calcium, and the other one will be ready for you to analyze for magnesium. What will you do? You will be analyzing standard solutions, which are solutions that have known concentrations of magnesium and calcium, and then you will prepare a tap water sample and run that sample through both the calcium and the magnesium spectrometers. How does it work? Well, the atomic absorption spectrometer has a lamp on one side, and let's assume we're looking at the calcium instrument here. The lamp will be filled with calcium vapor. Electricity is run through the lamp so that the ground state of calcium atoms will absorb the electricity and go to the excited state, and then the electrons will fall back to the ground state and emit the light that you see glowing from the calcium lamp. On the other side of the instrument, there's a flame. Your sample is going to be sucked into the flame, and the heat of the flame will cause the atoms in that sample to go to the excited state and back to the ground state, emitting light. Essentially, the instrument is looking for a match. And the match is reported as absorbance of light. The amount of light absorbed indicates the amount of calcium in the sample. The greater the absorption, the greater the concentration of calcium in the sample. How do you analyze the sample? Well, you're going to graph the data from the standard solutions. You'll have a graph. On the y-axis, you'll have absorbance, and on the x-axis, you'll have concentration in milligrams per liter. The standard samples are at 2, 5, 10, 15, and 25 milligrams per liter. And so you'll have points here, something like this, and you are going to graph these points in the form of a straight line. The equation that governs this relationship is called Beer's law. It is stated as absorbance is equal to the molar absorptivity, that's what epsilon represents here, times B, which is the path length, which should be 1 centimeter, times the concentration. And have a great lab.
Remember, the form of a straight line is y equals mx plus b. This fits the format of a straight line. B should be 0 on a good day. We're graphing the absorbance on the y-axis, the concentration on the x-axis. Therefore, the slope should be the molar absorptivity times the path length. So if you go back to your data and draw the best fit straight line, something like this. You'll either be using the LabQuest device to draw this line or Excel. In one case, you'll be doing it by hand, and you'll want to use a ruler to draw the best straight line. And from this, you can get the value of the slope and the y-intercept. Then for your unknown sample, what you have is the absorbance. That's what you'll be measuring on the instrument. So you'll know the value for y. You will already know the value for the slope and the y-intercept. So to find the concentration of calcium in your sample, you just rearrange this equation to solve for x, which is the value of C and the concentration in milligrams per liter. You do this for calcium and magnesium, and then you're going to compare your values to the values that are found in the hard water data table included in your lab manual. Don't forget to complete the pre-lab questions and have a great lab.